Hello all and welcome to lecture 6 for this Python programming series. We're in the home stretch, only a few more lectures to go and we'll be done with our Python class. So let's see what we're going to find out and learn today. So today we're going into a very large topic that is probably new to most of you, and it is a topic called classes. And within classes, we're going to talk about objects and functions and methods. So it's going to cover chapters 15, 16, 17. The next lecture is going to be 17 and 18. So we're going to be revisiting these same topics for the next couple of lectures, but today is going to be a good introduction to the world of object-oriented programming using classes. Object-oriented programming, or sometimes it's called OOP, it's a computer programming model. So it is the way that you are going to put your program together. And the idea behind it is that you're going to create an object, and that object is going to have attributes and methods rather than just putting out individual functions and logic and doing these command lines. Typically, we'll use objects for much larger, complex problems, but we're going to use it on a smaller scale just until we get comfortable with it. Object-oriented programming has this idea that you have an object such as a human, and the class is called human. We're all humans, and our object is a part of that class, or a type of class. So your object would be a name for a specific human. Within that object is going to have certain properties and methods that the object knows how to do. So the properties, here it says email and address. I would rather say things like hair color, skin color, things like that. They are things that just are about an object. So if you're thinking of a sentence, it's an object's nouns. Methods, on the other hand, are things that your object knows how to do. So for this, it has verify and send email. I like to think of it as, if we're thinking about a human, walk, talk, breathe. A human knows how to do all of those, regardless of what your properties are or what your name is, if that makes any sense. We have gone through so many different data types. Here's just kind of a snippet of a list. We've gone through integers and floats and strings, lists and dictionaries and booleans. But what if I wanted to create my own data type? And that's essentially what this object is. We are creating a data type within our programming language. So it is going to be a user-defined data type. When we think of these data types and we think of an int, we can do things to an int. We can give it a value, we can add it, we can multiply it, and it knows how to take care of itself. The same thing is going to happen with these user-defined objects. Let's take a much easier example than the human example. If I create a point in space, and let's think about 2D space. So say we're going to go back to math, and you're on an XY grid, and you create a point. That point is identified by its XY coordinates. So for example, I can say a point is at 4, 6. So my X value is 4, my Y value is 6. I can create an object called point where I store those coordinates in two separate variables, in X and Y, or I can store them as elements in a list or a tuple, doesn't really matter, but a point has to have an X and a Y. So can I create an object of a new data type that's called a point, that every point I create has an X and Y? Well, that's where this class goes. So it is a programmer-defined data type. and you create an object of that class. The object is going to be the variable name, and the class is going to be the data type. Just as if we say in C programming, for example, int number, right? We say data type and then variable. So int is the class, number is the class object. When we create a new object, we say we are creating an instance of that class. And you can have as many instances of the classes that you need to do what you want to do. So if I go back to my point and I create my class point, I can have 8 to 10 points or point objects in a program. That's not a problem. Now let's look at some syntax for creating a class. Here I've got on line 1 the keyword class with a lowercase c, and I name the class point with a capital P. Typically when we do these user-defined classes, they will start with a capital letter, and that is one of those programming rules of thumb that it's going to separate you from the less experienced programmers. But user-defined classes typically do start with a capital. On line 2, we have what we call a docstring, and the docstring will have 3 quotes on either end, and in the idle, if you're using that, it will turn it green. And that docstring is used for documentation of the class. So typically we'll have an explanation of what the class is and if the class has any attributes. And we'll see that in a little bit. Now, here at the bottom, if I were to go to my command prompt and just type in the class name, so capital P point, it's going to tell me that it is a class of this main, and it is of type point. So it gives you a little bit of information, but it does point out that it is a class. Now I can have attributes into my class, and the attributes are elements that we've given a name to that belong to a specific object. So for example, when we talked about that human, hair color, eye color, skin color, things like that. We are going to use the dot notation that we've gotten so used to using with Python. And we can assign values to these attributes within our class object by just saying object.attribute equals and giving it a value. So for example, if blank is my class object and it is of type class point with the capital P, I could say blank.x equals 3 and blank.y equals 4. And then that would be my ordered pair of 3, 4. You could also read the values by using that same dot notation. So it's class object dot attribute, and it would give you back the 4. So we say that it is going into the object blank and getting the value of the variable x that's in that class. Let's try another one. So we are going to look at a class rectangle. Now we did the point, which is cool, but if we were to identify a rectangle, what attributes would you use? So there's a few different ways we can do this. We can specify a single point and then a width and a height, or we could specify 2 corner points. Let's go ahead and use the point with the width and the height. So here you can see I've created a class rectangle, and now it has attributes width, height, and corner. And corner is of type point with the capital P. So you can use your user-defined data type classes within other classes. So here at the top, I have my header of my capital R rectangle, and it says it represents a rectangle, attributes, width, height, and corner. So we've added that line in our DocuString of what attributes are contained in my rectangle. So first I have my class point, and then I have my class rectangle, and point is just what we did before, no big deal. Here I can say box equals an instance of rectangle. So my rectangle object is now box. Then I can go in and say box.width equals 100, box.height equals 200, and then I can actually say box.corner equals point. And remember, point with that capital P is going to be that XY coordinate. Then I can stack my dot notations. So here I've got box.corner.x equals 0 and box.corner.y equals 0. So these last dot notation, the dot x and the dot y, those belong to the point, and the corner belongs to the box. So if I were to draw it out, it looks like this, like what we just saw on the previous slide. I've got a box, and a box is a width, a height, and a corner. My width has a value of 100, my height has a value of 200, and my corner is a point, which is a new rectangle here, because it contains an XY value. And here my XY value is just 0, 0, so it starts at the origin. So you can see how each one of these boxes is one of my user-defined data types, with the first one being the rectangle and the second one being point. I can also return classes. So here I have a function. So I've got my def find center, and I send it a rectangle. If I'm trying to calculate where the center of the rectangle is, okay? So P, I create a point because I want to send back the XY coordinates of whatever the center of that rectangle is. So I say P.x equals rectangle.corner.x. Remember, we just saw that. Plus rectangle width divided by 2. And then we do the same thing for the height, for the y. And then we return that new point P that we created. So this is taking a rectangle, capital R, class object. We're calling it rect, R-E-C-T. We're creating a new user-defined object, capital P point. We're giving it attribute values for X and Y, and we're returning the entire user-defined value of point back to whoever called this function. So it is going to return an instance of the point class. So remember, an instance just means a variable of that type. So it's returning that P, which is of type capital P point. Object states are going to be mutable, which, remember, we've used this word a lot this session, but it means you can change them. And we can just change them by assigning new variables, just as if we were to change any other variable in a Python code. So if here I can actually say my box width, I'm going to increase it by 50. So I say box.width equals box.width plus 50. And I can do the same thing with the height. I can grow my height of my rectangle by 100. So I say box height equals box height plus 100. And here I can even create a function that will grow my rectangle if I send it a rectangle and the width that I want it to grow and then the height I want it to grow. And all I do is I set the width and height to the original value plus the new value. There are a lot of built-in functions and methods in Python to work with classes. One of them is copy. So copy is a module, so we will need to import copy before using copy. And it's a very weird module because we can say copy.copy. And if we send it a class, it will make a copy of that class. So for example, here I say P2 equals a copy.copy of P1. If we remember back to our same conversation, it's going to be equivalent, but it's not going to be identical. So if you don't remember that, go back a few lectures and you'll remember what that means. In essence, it makes what we call a shallow copy. And a shallow copy means it copies the objects and the references, but it will not copy any embedded objects. So let's go back to our rectangle, because our rectangle had an embedded object of the corner point, if you remember. Here I can say box2 equals copy.copy of a box. If I say box2 is box, it's going to give me false, because remember, it's not identical, it is equivalent. Now, if I ask it if box2.corner is box.corner, it will give me true. So what's going on with this shallow copy? Well, here on this left-hand side, I have the same graphic that we used before to indicate our box class. I've got my width, my height, and my corner. My corner points to a new object of point, which is XY. When I do this shallow copy, which is the copy.copy, and it creates box 2, it gives me a whole new object with a width, a height, and a corner. The width has an equivalent value, the height has an equivalent value, but the corner actually has an identical value because it points to the same embedded object that was in the original. So if I were to change box.corner.x here and change it to 4, box2.corner.x would then also change to 4. Now, if that's not what you want or that's not what you expect, you can do something called a deep copy. And this is going to copy the objects, references, and make copies of those embedded objects. And the only difference is instead of copy.copy, it says copy.deep copy. When I do that, box 3 is box, false, and box 3.corner is box.corner. That will also give me false because they are no longer identical in any way, shape, or form. They are only equivalent copies. Classes and functions. So we can take our classes and make it do things. So our functions are going to be our verbs. Our attributes typically are our nouns. So here I have a brand new class called time with a capital T, and its attributes or the nouns that are associated with it are going to be hour, minute, and second, right? Hour, minute, and second are going to be things on time that you can do things to. So here I create an instance of time and I call it time with a little t. That is completely legal because remember, case sensitive. Then I can say time.hour equals 11, time.minute equals 59, and time.second equals 30. And remember, we'll go back to this graphic with classes, and on the right we see it has a object, time, and it contains hour, minute, and second, the attributes. And my time, little t, is pointing to that object, so it's the class object with the values 11, 59, and 30. Now, if I want my class to do something, so say a verb, I create a function within that class to do it. So for example, let's do a function to print underscore time. So here I can create just a regular function and I can say def print time, send it an object time, and I call it time with a little t, and then I can print time.hour, time.minute, time.second. I can have two different types of functions. I can either have a pure function or a modifier. When we work with classes, it's sort of like the fruitful and the void functions, but it actually indicates what we do with a class in particular. So a pure function is not going to modify any object passed to its arguments. It's not going to modify it in any way, shape, or form. It only is going to return a value. A modifier is going to modify that object in some way, shape, or form. Here we have an example of a pure function. So add time. We're going to create an object time. We're setting an hour, minute, and second. And then we are doing a sum. And so we are adding time 1 to time 2. So here we add the hours, we add the minutes, add the seconds. If the seconds are over 60 seconds, it converts that to minutes. And then at the bottom, if the minutes are over 60, we then convert that to hours. So even though it creates an object and it gives it some initial values, it's not modifying an object that was sent to it. So it is considered a pure function. So for here, it's just going to take two values, time 1, time 2, and it is going to return the sum of those because we don't actually change T1 or T2. So therefore, it's considered a pure function. Now, a modifier would be if we were to increment a time object by a given number of seconds. So here, time.second plus equals seconds. That's where it becomes the modifier, because you're taking the object that is sent to it, time, and you are changing the seconds. You're actually incrementing it. So that's what's modifying. And then you're going to further modify it by updating 6 seconds to minutes and then minutes to hours if you pass that 60 threshold. We are going to stick with the functional programming style. So what we are going to do is we are going to stick with writing pure functions. We don't want our functions to modify objects in any way, shape, or form. The only time we're going to modify is if there is absolutely no other way in order to accomplish the same thing. So our functions from here on out are only going to take input and produce output. We're not doing any kind of modification to any type of object. So we're not going to have any what we call internal state changes that are affecting that object. And internal state changes would be, for example, changing the minutes, seconds, and hours of that time object because they are within the time object. Now, so far, what we've done is not really object-oriented programming. We've been learning all of the ground rules and the basics. We've taken our object and we've given it attributes. But what is missing is the relationship between these data types and these new user-defined types and functions. Remember, functions are the verbs. What we are going to do is we are going to take those functions that are outside of the class and we're going to transform them into the methods. And it is going to make those verbs explicit to the class. So the class is now going to absorb some of these verbs. And what that's going to do is it is going to make the relationship between the types and the functions explicit. So they are going to know exactly who, what, where, when, how, and why. So if I return back to my object-oriented programming example that I had at the very beginning, I've got some definitions. Remember, we've already kind of touched on class, object, and properties, but what we have left are the methods. Method is going to be a computation or an operation on an object, okay? And remember, your objects are going to reflect like real things. So my objects and my methods are going to be doing real things. So again, if I was looking at my human class, here the methods say verify, send, email. I like to think of it more as walk, talk, breathe. Okay? A human just knows how to walk. A human just knows how to talk and to breathe. So it's representing a real thing when it comes to a human. So remember, we said we're going to keep our functions as pure functions. We don't want to modify the objects. Well, then how do we modify the objects? Well, we create a method within the class to modify it itself. So a method is nothing more than a function associated with a particular class to do a specific activity on the class. Now, really, methods and functions can be used interchangeably, except that methods are defined within a class and functions are going to be outside of a class. So everything we've done up to now have been functions. If I were to take the exact same syntax and put it within a user-defined class, it now becomes a method. So the syntax for the two are going to be very, very similar, but they're slightly different. So here, if I'm going to revisit that print underscore time function that I created, here I've got class time and I've got a separate function, def, define the function. And I have the print. So if I were to use this, I say start equals time, hour equals 9, minute equals 45, second equals 0, print time, start, and it prints my time out. Now, if I want to put that function inside of my class and make it a method, I can just scoot it up and indent it over for class. Okay, so you can see the syntax exactly the same, except that it is shifted to the right by a tab, and it is now associated with above it class time. So here my class is the subject or the noun. The method is going to be the verb. It's going to do something. So in our case here, it's going to print the time. So here I can say start.time, hour equals, minute equals, second equals. Then I can just say time.printtime. Here I can send it start, but I can also send it nothing. If I send it nothing, it's going to take the object in which it lives. So for our example, it's the same thing. Let's take a look at another example. I have two methods in my class time. My first method is going to convert time into seconds, and my second one is going to take the number of seconds and create a new instance of the class time from them. We're going to use them because we're going to create within the class time a method to increment the time a given number of seconds. Now, one thing to notice here, I send it something called self. Self is used a lot in programming, especially object-oriented programming, and self is an indicator of the instance of the object of the class that calls it. Okay, again, it's an instance of the object of the class that calls it. And we'll see an example when we get down to our command line. So here I take in the method increment, I take a number of seconds. I say self.timeToInt, so I take the time I have and I convert it to seconds. And I add to it the number of seconds. And then I return the time with the number of seconds added to it. So, for example, let's come down here. We have start.printtime, which is what we've had before, and we have 9:45. I can say then end equals start.increment. That is what is going to give you the value of that self, because start is calling the method increment. It wants the values located in start. Start is the self. And then I'm going to send it 1,337 seconds. Finally, if I end dot print time, so I print the value held in end, it's going to be 9:45 plus the 1,337 seconds, which gives me a new time of 10:07:17. Let's look at it and get a little bit more complicated. So here I'm still within my time class, and I can create a method called isAfter. And this method will compare two time class objects. So here I've got it using its self and another, someone else. And I can return if my self time is greater than the other time. What I end up doing is, here I had end before, so I can call end dot isAfter start, and the answer is true. When we create methods within classes, we will use names and words and verbs to indicate what that method is doing to the object or what it's returning. So if I were to look at this call in English, I could make it a sentence by saying end isAfter start, question mark. End isAfter start? Yes, it is, so my answer is true. That only works because I gave my method a name that is indicating what it's doing, right? So it is comparing if a value is after what I am. You will see a lot of times these verbs in class methods such as is, print, set, get. And it's going to indicate exactly what it's doing. So that's what makes it a good programming method versus just one that works. Okay, that's all I'm going to go into as far as the classes, methods, and functions, at least for this lecture. We are going to keep repeating this the next couple of lectures and go through and extend it a little bit more. But the last thing I do want to touch on in this lecture is something that we do, which is the initialization of classes. So here you can see there's a lot different syntax going on. I've got a double underscore, and it's called init for initialization with a double underscore. That is a very special method within a user-defined class. Every class has an initialization method. When you do a user-defined class, the user must define what this init does. So here, for example, I'm saying within myself, hour equals 0, minute equals 0, second equals 0. Again, very different syntax than what we're used to seeing. We've got parameters and attributes having the same name for one, and that is a common practice. For two, we've got these equal signs in our argument list. That we've never had that before. And then we've got these values. So there's a few different things going on. When the initialization is run, and it is run every time you say time equals time, for example, right here. Every time a new instance of that class is created, the init method is run. It's the very first thing that's done. So if I have this self-defined init here, I've got self.hour equals hour, self.minute equals minute, and self.second equals second. Well, that would make sense if I didn't have these equals and the zeros on it, right? But I do. What that does is it gives me flexibility. So here, for example, if nothing is specified, I give it a 0. If nothing is specified, I give it a 0. And if nothing is specified, I make it 0. So I'm able to say something such as time equals capital time, and it actually has values in hour, minute, and seconds of 0, 0, 0. And the only reason why it has those values is because of this hour equals 0, minute equals 0, second equals 0. Now I can also change that. So if I say time equals time and I send it a 9, it's going to take that 9 and put it in the first value of hour. There's nothing for minute, so it stays at the 0. There's nothing for second, so it stays at the 0. So when I print this time, it's going to give me an hour of 9, minute of 0, and second of 0. I can also go ahead and send it 2 different values, or even 3. And this is that flexibility that I was talking about. So here, time equals 9:45. It is going to create a time with an hour of 9 and a minute of 45. I didn't specify seconds, so it's going to resort back to the default of 0. So when I print that time, it's going to give me 9:45, 0, 0. So remember, it's going to set the attributes within the class to an initial value so we know what's there. Most of the time, if nothing is sent, everything is zeros, empty strings, things of that nature, just so that they're created and we know what's in them. But you can send values to init like we did with this time. We covered a lot of object-oriented programming today when it comes to Python. So we covered what classes and objects, functions, and methods. Again, we're going to be repeating and reviewing a lot of these ideas and these topics in the next couple of lectures through the end of this course. So please don't be afraid if you don't understand in this one. We'll get you caught up eventually. We'll see you next lecture.